Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hi, it's Mr. T, and today we're going to be talking about solving exponential equations. Today we're going to be solving it using a graphing utility. Let's talk about why we might want to solve a exponential equation. So I've listed here two typical applications. There's lots of real-world applications for exponential models. We had a whole unit on exponential growth and decay. So here, the first example we purchased a car, and maybe we want to plan on trading it in or selling it when the value gets to a certain point, and we want to know how long that will be. So in a minute, we're going to work through this example that we have here where we purchased a car for $35,499, and we want to know how many years it's going to be until the value will decline to $10,000. And we've researched, and this car has a depreciation rate of 17%. Another one might be planning for an investment. Maybe you've gotten a inheritance or a gift from graduation or something, and you want to say, how long will it take for me to double my money? And we're going to look at that. We've just recently had continuously compounded interest. So we'll write these equations and see that they're exponential equations. Now, exponential equations are ones where the unknown, the x, is an exponent. So let's look at our first application. Now note down here at the bottom, if we wanted to solve these equations that we're going to have, we'll write the equation in a minute, we would have to use something called logarithms, which are the inverse of exponential equations or exponential functions to solve these algebraically. There is another video and tutorial on logarithms and applying those to solve exponential functions if you're interested. So again, if you remember, we're using here our exponential model for exponential growth and decay model. And A, remember, is our initial amount. So our model here is going to be 35,499. And remember, B is a growth or decay factor, and when we're doing percent decrease, we find B by doing 1 minus the rate, where the rate is this number divided by 100. So our B value here is going to be 1 minus 0.17 or 0.83. And to the x. Now that's our model. Now what we're wanting to solve is when the value, which is y, is 10,000. So we're wanting to solve this equation here. So as you can see, it's an exponential equation because our unknown is an exponent. So if we were trying to get this x by itself, we could divide by here. But now how do we get that x out of the exponent? And again, to do that, we would have to use the inverse operation of exponentiation, which is logarithms. And again, there's a separate video. So we're going to use a graphing utility to solve this. And essentially, we're treating this as a systems of equations. So we have two equations. So one equation, call it y1, is this constant function 10,000, and our second equation, y2, is our exponential equation. And we want to know when they're equal. Well, to solve a system of equations using a graphing utility, what we're looking for are where these two functions intersect, where they cross. So let's power on the graphing calculator, and we'll get into the graphing mode. So we press the y equals. And we're going to put one side of the equation into, say, function y1, so 10,000. And we're going to put our other side of the equation into y2. Times 0.83 raised to the x power. Now we could press a graph. Now my window had some other value. If we want to get to the default window, we could be pressing zoom 6, but we're not going to see anything here. Now our Y values are quite large. The initial value is 35,499. In the default mode, this only goes up to 10. So we need to adjust the screen so that we can see these curves. So we need to press the window button here. And since we're dealing with time, we're not interested in negative time. So we could take it out to 10 years. We'll see if our intersection happens in 10 years. And the Y values, we want to go up to at least 35,000. So I'm going to go up to 40,000. And so that the tick marks aren't all blurred together, we'll set the tick marks, the Y scale, to be 5,000. It's optional for setting this. It just makes the graph look cleaner. And let's press graph. So this is the 10,000, Y equals 10,000, and this is our exponential model. We've talked about graphing exponential models, and we have this shape for exponential decay. We're interested in the X value of this intersection point. So to find intersections, we're going to use this calc menu on the graphing part of the calculator. So I'm going to press second, and then calc, and we can select item 5, which is intersect. Now to do the intersection, it's going to ask you to move the cursor near where the intersection is. Now we want to use the left and right buttons. If you use the up and right arrows, it toggles between the curves. So we want to go left and right. So we're on the linear function. We want to go to where it's near the intersection. Now we're going to press enter. Now it's asking us to put it near the intersection on this second curve. Well, it's already there. We just set enter. It asks us to make a guess. We just press enter. And now we look at the X coordinate because we were finding X. So for our solution here, we have X equals approximately 6.8 years. So towards the end of our 6th year, or as we get to 7 years, the value of our car based on this depreciation rate is going to be down to $10,000. Now, if you don't have a graphing utility but have access to the internet, we can also use a graphing utility on the internet that we've used at other times called Desmos. So I've brought up my Desmos calculator. So it's at www.desmos.com/calculator. And I've put in our two sides of the equation. So Y1 I put in as Y equals 10,000 and our exponential model. You just type it in here. Now again, the default scale here goes from plus or minus 5. So we need to go in and change the view. So you click the wrench here and we can set our X and Y axes. So let's set X to go from 0 to, we'll just do 10 again. And Y, just like we did in the graphing calculator, will go from, say, 0 to 40,000. Now we can click in here. Now we've got our graphs. Now we're looking at this point. So if we click the mouse near that point, it'll highlight a dot there, which will be the intersection point. So now we have our x-intercept, which is the same as the 4, about 6.8. So you can use a graphing calculator if you have it, or you have the emulator of the graphing calculator that I've put on my website, or you can use Desmos. All right, let's look at our second example. Now to model this, we're going to use the continuously compounded interest model. Our PERT model. Remember, R is the interest rate or investment rate converted to decimal, so 8% divided by 10, so 0.08. Now, there is no initial amount here, but we're doubling it. So if P was 1, A would be 2. If P was 100, A would be 200. You can pick any number you want. So I'm just going to pick 1 for my initial amount. And A, we want it to double. So A is going to be twice that, 2 times P. Again, we could pick any number here. We could pick 100, 200, 1,000, 2,000. The solution for the number of years will be the same. So again, our model we're going to be looking at here is going to be 1 times e to the 0.08 t. So we're going to do the same thing with our graphing calculator. We're going to, let me get rid of our old equations. We're going to put our left side into y1, and our right side we will put into side 2. So remember, we press second and the ln button to get the e to the power, and now we have 0.08 x or t. And I'm going to put zoom 6 to reset our window. So here's the y equals 2. This is our exponential function. And again, we're going to find the intersection. So second calc, item 5. Move out to near where the intersection is. It's somewhere around there. And press enter 3 times. Enter, enter, enter. And we get about 8.7 years. So t is going to be approximately 8.7 years. Now, what if we wanted to be more conservative in our planning? So what if we assumed and we changed our assumption on the investment return to be 5%? Let's assume our interest rate's 5%. So let's go back to y equals, and let's change our interest rate to 5%. So now we can graph again. Now it looks like the intersection may be off the screen, so I've got to go into window and we need to go out to more years. So let's change this to say 20 years. Press graph again. So now our curve goes up above the line, so we know we have the intersection in our viewing window. So now we can press the second calc, select item 5, and move over to anywhere near the area, somewhere in there. Press enter 3 times, and we get our time would be 13.9 years. So you see a relatively small number of change in the interest rate going from 8% to 5% makes a big difference in the number of years that we have to wait to double our money. So hopefully this will help you in terms of solving your exponential function. So again, we are setting each side of the equation into 2 different equations, y1 and y2, and then the solution of this system of equations is our intersection point. So have a great day.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you